Kraken. I'd like to introduce this tactile sensor being developed by a group and now being commercialized by a startup called Contactile in Australia. This is our first dev kit, so we've been selling this for over a year. Each sensor has 9 pillars. Each pillar can measure displacement in X, Y, and Z to within a few tens of microns, and force simultaneously measure force in X, Y, and Z to within a few tens of millinewtons. And we get some nice emerging properties such as torque in 3 dimensions, global force in 3 dimensions as well. The paper or the work that we're presenting is the use of this sensor. The sensor, it's difficult to see, is actually designed in such a way that the pillars have different heights, and that's intentional so that we have a traction differential across the pillars, and we encourage the smaller pillars to slip earlier. This sort of incipient slip allows us to estimate friction. When we detect the slip event, we measure the forces of the pillar that has slipped, and we take the ratio of normal tangential force to try to figure out what the friction is. And therefore, since we can measure the normal force and the tangential force globally, which is the weight of the object and the grip force, and we have an estimate of coefficient of friction, we can adjust the grip force almost optimally with some small safety margin. So here's one example here. If you're curious, the tactile sensor, just to go back a step, is also optical, but it's not camera based. So it uses a camera obscura approach where we reflect light off a reflector that scatters light everywhere. Some of the light comes through a pinhole and projects onto a quadrant photodiode. And with the 4 photocurrent readings, we can infer the 3-dimensional displacement of the reflector and hence the force and displacement. And what's the advantage of this is that we get very high bandwidth, so we can measure vibration at very high frequency. And it's quite pleasing to listen to a piece of paper running across the top of these sensors and listening to the force feed, the force and displacement signal. And finally, just to end my time, we're trying to miniaturize this, and one effort is with a single element, which is in collaboration with this video. Just take a moment. Oh, hang on. Sorry. My presentation decided to end itself.
Okay, excellent.
Sorry, I just have one video I'd like to show.
Okay.
Maybe will not load, which is unfortunate. No, it's not gonna play, and I've used my time. So thanks everybody for your attention. And come and have a chat to me in the Gathertown. I'll show you some more videos.
Okay, thank you very much.
Cheers.
Thank you.